Hello friends, welcome back to my YouTube channel MS Maths. In this video, I will discuss previous year question of GATE mathematics, basically the question asked in the engineering mathematics. So the topic is numerical analysis. So we'll discuss 20 plus year previous year question. Around 70 plus question I will discuss. So here we will have the questions from the paper civil engineering, mechanical engineering, electrical engineering, electronics engineering, instrumental engineering, and computer science and IT. So all the questions of numerical analysis have been collected, and now we'll get the solution in the easiest way, and I will explain 70 plus question from the last 20 years. So before going to start, I just want to say you can visit my numerical analysis playlist where I have explained all the things related to numerical analysis, related to topics of numerical analysis, basically interpolation. The important topics are interpolation, or we can say numerical linear algebra or numerical algebra, or interpolation. Okay, interpolation. And then the main thing is the solution of like transcendental equation, solution of transcendental equations, which is covered in the basically the topic covered in this section is basically the Newton's method, secant method, Taylor-Falsey bisection method. And after that, the important is something differentiation and integration. So numerical integration and differentiation is a very big, huge number of questions in, especially in mechanical engineering, and it has a big weightage of number also in GATE engineering mathematics. So basically, the topic covered in this section is something related to Simpson's method, trapezoidal integration, basically Simpson's 1/3, 3/8, and also Waddell's rules are also there. And differentiation is something numerical differentiation related to differential equation also, that is more important topic is something differential equation. So all the questions, all the types of question we'll discuss in this video. So you should watch at the end of the video, so you will get all the questions, and the basically the nature of question or the trend of question you will get. Okay, so we'll discuss basically branch wise. First we'll take something like, let's say this, like civil engineering, and then mechanical engineering, and then CS and something. So we'll take it a branch wise, so that you will have an idea that what is the trend going on the like questions, and what type of questions are asking. So after that, there are some topics related to system of linear equation, basically the Gauss elimination method, Jacobi iteration method. So these all questions we'll discuss in this section. So let's start the video. So we'll have a first question from the mechanical engineering. So this is basically, I will discuss here. This is from mechanical engineering. And the question is basically the accuracy of Simpson's rule quadrature for step size h. So what is the Simpson's rule? It is a like simple rule to solve or a method to solve integration. So the numerical, or basically the numerical integration is something like numerical integration. It is a method to solve numerical integration. It is basically Simpson's. Okay. So in which basically the order, they are asking about the order of numerical like integration or the accuracy. Basically accuracy means the order in this case. So just remind that in that case you will have three types of especially the important types of numerical integration is something trapezoidal. Okay, trapezoidal. If you are asking about trapezoidal, then the error is something h square by 12 and something. So it means it is an order of 2. So in the case of trapezoidal, it is the order of 2. In the case of Simpson, it is basically the error is something like that, minus of b minus a upon 180 h power 4 and the fourth derivative of some psi. It is nothing but if you are going to integrate something from a to b, the let's say function f of x dx. In that case, if I am going to Okay, let's say this is the exact one. Okay, this is exact integration, and I am like subtracting to find the error. I'm subtracting the Simpson's rule. Simpson's basically the answer getting from the Simpson's formula. That is something SL. So this is what the error, and you are getting here that it is what the order fourth order. Okay, it is what fourth order. So it means the C answer is correct here because this is the fourth order Simpson's accuracy. Okay. The next question is from again mechanical engineering. This is GATE 2025, 2005 2 marks question starting from x0 is equals to 1. Okay, this is what something related to Newton-Raphson equation. This is the algebraic equation. Let's say my function f of x is equals to x cube minus 3x plus 7. Okay, so the initial guess is something x0 is equals to 1. This is given and solved using the Newton-Raphson method. So first of all, what is the formula for Newton-Raphson method? You should know about this. This is the formula xn plus 1 is equals to xn minus f of xn divided by f dash of xn. This is what the differentiation of the function. So first I will start with n is equals to 0, then it will be x1 is equals to x0 minus f of x0 upon f dash of x0. So what is your x0? It is given. It is nothing but x0 is equals to 1 and the function is something x cube minus 3x plus 7. Then the derivative of the function will be f dash of x is 3x square minus 3. So find all the values in at x is like x0 is equals to 1. So we are asking about that x1. What is the x1? So x1 is nothing but what is x0? X0 is 1. So it is 1 minus f of x0. So it is something like that. If I will put 1 here, then it will be 1 cube minus 3, 1 plus 7. And this is nothing but minus of 3. So it is minus of 3. And if I will put 1 here, then 3, 1 square, 3. Sorry for that. It is 3 x square minus 3 and it is what x1 is this plus. Okay, it is what the plus. Sorry for that. I am writing it as minus. It is plus minus. It is plus and it is minus. Yes, that's why it is minus 3 and it is plus 6 because it will be 0. So x1 is equals to 1 minus or 1 plus basically 1 by 2, then x1 is equals to 3 by 2, that is nothing but 1.5. So the C is the correct answer. So let's move to the next question. It is a calculator has accuracy up to 8 digit after decimal places. Okay, and the value of this integration 0 to 2 pi sine x dx. So we are asking about the integration 0 to 2 pi sine x dx when evaluated using the calculator by trapezoidal method with 8 equal intervals to 5 significant digit. So basically it is saying that your answer should be 5 decimal places correct. Okay, let's see, start. So what is the formula for trapezoidal? So first of all, you should have an idea about what is the formula of the trapezoidal one. So this is nothing but whenever you will have any type of like function and you are going to integrate it about a to b, it is a basically definite integral, or the formula will be if you are discretizing your function, let's say my y is nothing but f of x. So I will just write y0, y1, y2. It is like something discretization up to n number of points. So in this case, it is saying that it is divided in 8 equal interval. So there will be 8 number of values from 0 to 8. It will be n plus 1. So 9 interval. Oh, sorry, 9 points. 9 points. Because of that, if it is 2 points, if it is a line, or I say it is 0 and it is 2 pi, then it will be 0 and this will be 1 and next one will be 2 interval, next one will be 3 interval. It means the main thing is here you have to calculate step size. What is the step size? So h is the step size, that is nothing but b minus a upon the number of intervals, that is n. So you are calculating h is nothing but 2 pi minus 0 divided by 8 is nothing but pi by 4. So it will be your step size in this case. So you have to calculate all the values in this case. So let's say I'm going to making a table. So let's say it is my x Okay, here it is my x, and here it will be y is equals to sine of x. Okay, so let's say at 0, sine 0 is obviously 0, and let's say sine pi by 4, sine pi by 4 is 0.707. Okay, you should know all these values, or it should be 5 significant digit. It means this should also be written in 5 significant digit. And let's say next will be pi by 2, and it will be 1. Okay, next will be 3 pi by 2. Oh, sorry, yeah. Next will be 3 pi by 4. Then it is 0.70710. And next will be pi. This will be 0. And next will be minus of, yes, it will be 5 pi by 4. Then this will be minus of 0.70. These are the value you can calculate it from. Okay, you can calculate it from basically this is nothing but you can say 3 pi by 2 in this case. This will be minus of 1. It will be in another quadrant, and you can calculate it by using calculator. Okay, and next will be 7 pi by 4. That will be again minus 0.7010 or minus 0.70710, and at the end it will be 2 pi, it will be 0. So you will have all these value, and I'm going to saying these are my values. I'm calling it as y0, y1, y2, y3, y4, y5, y6, y7, and y8 are there. So it is 0 plus 8. It means 9 points are there. So now what is the formula for trapezoidal? The formula is basically y0 plus yn divided by like h by 2. Okay, you can write it as something like this. There is a two way to write the formula. The basic formula is something a to b f of x dx is something h by 2. Okay, and after that you will write y0 plus yn. N means what is your like what will be the last point? It is y8. So here it will be y8. Okay, and after that the twice of all remaining points. So it will be from y1 to y2 plus y3 up to yn minus 1. Okay, so now you will have all these value, and if n is equals to 8, then after putting all these value, you will get up to 5 significant digit. Okay, this is more important. Up to 5 significant digit, it will be 0.00000. So the first answer is correct in this case. Okay, let's start the next question. This is what the from mechanical engineering GATE 2010. It is torque extracted on a flywheel over a cycle is listed in this table. So these are the data given in this case. Here angle and torque are measured, and basically flywheel energy in J, basically joule per unit cycle using Simpson's rule. So calculate the energy, or basically it is nothing but the integration. So using the Simpson's rule, we have to calculate the integration. So what are the data given? Data is something like that. It is like basically energy is or basically the torque is function of angle. So we can calculate torque is something or some function of phi or theta. So in this case, my T1 or basically tau 1, we can say it is okay. Yeah, T1 we can say. So this will be T0, this will be T1, T2, T3, T4, T5, and T6 are there. Now, what is the formula for basically for Simpson's 1 by 3? Okay, Simpson's rule, we can generally use Simpson's 1 by 3. Either you can use Simpson 3 by 8 or Simpson 1 by 3. I am using here Simpson 1 by 3. So if it is not mentioned, then you can easily apply Simpson 1 by 3. Okay. So now if the integration is basically the formula is h by 3. Okay, 1 by 3 means h by 3 you are taking, and again the h is nothing but your angle, like angle from where to where, 0 to 360 means 2 pi. So it is what? B minus A upon N. Again, I'm going to calculate h here. So if you want to take h, or here you have 6 points. So N is nothing but 6. So you will have 2 pi minus 0 divided by 6. Then you will get h easily. That is pi by 3. Okay. Now in this case, I think you don't need any kind of h. Because of that, the data is given. So you will put just in the formula. The formula is something like that. T0, it means you will have to start from this T0 plus Tn. Again, this is first plus last n. twice of all odd number of points. It means it will be T2 plus T4 plus T6. It will be not odd, even number, sorry. So it will be even number. And the fourth multiply of odd numbers. It means T1 plus T3 and something. It will be odd. Now you will have the points, or you can put it easily, that is h by 3. Then it will be T0 plus T6 will be there, and twice of all the even number points, that is nothing but T2 plus T4 and T6 are there. T6 it will be written here because of it that the last point should be here. Okay, so T2 and T4 will be there, and plus 4 of this T1 plus T3 plus T4 will T5 will be there. Now after putting all these value, you will get the answer 993. So the B answer is the correct answer in this case. Okay, now let's start. Let's move to the next question. So next is again related to the integration, and again it is Simpson 1 by 3. So it is nothing but 1 2 3 1 by x dx. Sometimes you will have data and sometimes you will not have data and you will have any function. So here my function f of x is nothing but 1 by x, and I have a is equals to 1, b is equals to 3. Then I can easily find my h. Okay, here given the length is 1. Okay, interval size is 1. It means it will be something like this. 3 minus 1 upon 1 is equals to 2. So my h will be okay, the length is okay, wait, the length is given. It means h is given as, wait, h is equals to 1. It means I will find n. Okay, so it will be 1, 3. 1 3 minus 1, 2 by 1, it will be 2. Okay, so 2 interval will be there. It means I will have x0, that is 1, and the value is 1. X2, x1 is nothing but 1 plus 1. It will be 2. Okay, it means my x0 is equals to x0 plus, xn plus 1 is equals to xn plus h. Okay, like previous one we can add into h. So it will be 2, and now put here it will be 1 by 2, and at x is equals to 2, that is 3, and it will be 1 by 3. So this is what my y0, y1, y2. Now you can put all these values. Then what is the formula? The formula is something integration, I is nothing but h by 3. Okay, now here first point plus last point. Okay, first point plus last point is 2, plus twice into even multiplication. Is there any even multiplication? No. So it will be 0. And fourth multiple of odd. Yes, it is odd, y1. After putting all these value, you will get 1.111. So the C answer is the correct answer. Okay. So the next question is again related to something basic of numerical analysis. That is what the case here. Match the correct pairs. Numerical integration is here, and the order of the fitting polynomial. It is also related to the numerical integration. In mechanical engineering, most of the question related to numerical integration. So if you will learn two to three formulas, you will easily get full marks in numerical analysis. So basically, here you will have trapezoidal, Simpson 1 by 3 and Simpson 3 by 8. It is very clear. Whenever you will have numerical integration, just note it down that trapezoidal will give the more accurate answer on only linear polynomial. Okay, so it will give more generalized answer, or it will fit the data to the non-linear, the linear, not only not on non-linear, it is just on linear. So it will integrate, or it will give the more accurate answer on linear polynomial. And in the other hand, if I will have Simpsons, okay, Simpsons 1 by 3, then it will be second order polynomial. Basically, we can say that second order polynomial like parabolic, okay, parabolic kind of like this kind of polynomial. And third one is Simpson 3 by 8 is basically third degree or third order polynomial, whatever we can say. So these will be the order. So now you can easily see here trapezoidal will be the first, this will be second. So I think q is 1, so the q is 1. So in this case, the correct answer will be D. Okay, so D will be the correct answer in this case. Okay, next case we will have the real root of the equation 5x minus 2 cos x minus 1. So what is the real root? So it is we can calculate it using any kind of numerical method. So I'm using here Newton-Raphson method that we have already used. So using Newton-Raphson method, we have, so the formula is basically xn plus 1 is equals to xn minus f of xn divided by f dash of xn. So basically the function f of x is nothing but this is my function, that is 5x minus 2 cos of x minus 1, and the derivative of the function is 5 minus, or basically 5 plus 2 sine of x. Okay, so this is the derivative and I am taking the initial guess. So what will be my initial guess in this case? So first of all, if I will take any kind of for example, I will start the initial guess from, I can start from 0, I can start from 1. Okay, so in this case, if I'm going to start with x0 is equals to 1, this one is the radian quantity. This is not basically the, you can say, degree. It is a radian quantity. So while calculating in the calculator, you should have mode of calculator should be in radian. Okay, or if you are not taking radian, so just put x0 is equals to 75.32 degree. Okay, 1 radian is something related to 75.32 degree. Okay, this is what 1 radian. So if you are putting 1, then it is no problem. So I am just putting this value. Okay, this degree is this degree form of this. So I will get x1 is equals to 1 minus 5 into 1. Okay, 5, and x is what? Okay, in the case of x, you should put 1. Okay, because in this case there is no matter of radian, because while the problematic in the only the problem in the only angle, it is 1 minus 2 cos of, it will be 57.32 or 32 degree minus 1. Okay, and divide by 5 plus 2 into sine 57.32, and this will be 0.5632. Okay, this is up to 2 decimal places. So now again, what is x2? X2 is 1 minus. Oh, no, sorry, it is not 1 minus. It is the previous one. Now, this one will be the xn. So it will be 0.5632 minus 5 into 0.5632 minus 2 cos of. Now, what is the value equivalent to radian for this? So this one is radian and the degree form is 32.27 degree. So it will be 32.27 degree minus 1. So divided by 5 plus 2 sine of 32.27 degree. Okay, so now it will be 0.5425. Now just seeing, it is 5.6 and it is 5 sorry, it is 0.56 and it is 0.54. So this is not two places accurate. So I will just calculate x3 here. So it will be 0.5425 minus 5 into 0.5425 minus 2 into cos of. Okay, so what is the equivalent degree value of this is 31.09 degree. So it will be 31.09 degree minus 1 divided by 5 plus 2 sine of 31.09. So it will be, the answer is basically 0.5424. Now see, it is what? Two decimal places accurate result. So the answer is 0.5424. This is the correct answer. Okay, next, it is again related to integration, and now it is related to trapezoidal integration. The same question. Basically, now your function f of x is equals to log of x. Okay, so basically, if it is ln, then it is log base e. So you should write ln. So you should select ln in the calculator. Okay, so now your a is equals to 2.5 and b is equals to 4, and using the trapezoidal with 5 subinterval, now you will have n is 5, so you can easily find h. It is b minus a upon n, which is nothing but 4 minus 2.5 divided by 5, which is nothing but 0.3. Now the formula, so basically the formula of trapezoidal we can easily find, that is what I is equals to something h by 2, okay, y0 plus yn, last term, plus twice of all remaining term, y1 plus y2 up to yn minus 1. Now you will have function this, so you will just put x0 is equals to 2.5, and basically the log of 2.5 is nothing but, I have calculated value, that is 0.1963. Similarly at x1 is nothing but your 2.8 will be, the value will be 1.0296, okay, and at x2 which is 0.31 and the value will be 1.1314. x3 is equals to 3.4 and the value of the function is 1.2237. x4 is equals to x4 is equals to 3.7 and the value is 1.3083, and x5 is equals to 4, that is the last point, and the value at is 1.3863. Now on putting all these value, which is y0, y1, y2, y3 and y4, so while putting all these value, we are getting it as, we are getting the result is something related to 1.7533. So this will be the correct answer, 1.7533. Okay, next. So the next problem is again related to integration, and now it is related to again, okay, it is 2024 and it is also, this is 1 mark question. Here it is given, okay, I think it is a repeated question. Okay, it is repeated, we have already done it. Okay, 1 by 3 and 1 by, okay, by taking 1, it is a repeated question. Next one is, okay, yeah, this one is important question. This is also again related to numerical analysis, integration, numerical integration. Basically we can first find h, that is what, minus 1, or basically 1 minus minus 1 divided by the interval is basically 3 equals sub interval. So now it will be 2 by 3 and it means 0.667. Now the function is mod of x. Okay, so it will be x and here will be f of x is equals to mod of x. So if it is minus 1, okay, it is not straight. Okay, yeah, it is straight now. Minus 1 is, mod 1 is 1, minus 0.333. It is nothing but 0.333. And now 0.333 is basically 0.333. And now 1 is 1. So these are the value. This is what, y0, y1, y2, y3. For putting all these value, on putting these values in trapezoidal formula, we are getting the result is 1.11. So this is the correct answer. Next, consider an ordinary differential equation. This is related to differential equation, and the method is basically the Runge-Kutta. Okay, so dx by dt is the equation, given differential equation, dx by dt is equals to 4t plus 4. If I will start at x is equals to x0 at t is equals to 0, it means something related to x0 is equals to x0, which is given as initial value, condition or initial value. This is called initial value problem. Now if my delta t is equals to, okay, now this is what related to delta t is equals to 0.2, the step size is this, then multi-step method, fourth order, Runge-Kutta fourth order multi-step method, then what is the basically calculate, and the increment in x calculated using this, then what is the x? So basically we are calculating x here, or basically the increment, and increment will be nothing but the value in Runge-Kutta method. Basically we will have multi-step method like this. The formula of Runge-Kutta method and the solution is y0, y is equals to, okay, y is equals to y0, or basically we can say yn plus 1, or this will be yn plus 1 is equals to yn plus something k. What is k here? This will represent the increment in x, okay, like this. This is what the increment in x 2.0, and what is the basically x0 here. So we are getting the solution from this. So it is basically yn plus 1 is then the k is nothing but k1 plus 2k2 plus 2k3 plus k4 divided by 4, divided by 6, not 4, sorry for that. It is divided by 6. So now what is k1? So we are calculating k1. K1 is nothing but h into f of x0 and t0. Okay, f of basically we can write it as, because it is independent variable is x0 na? So t0 and x0. So what is my function? Function is 4t plus 4. Now here in this case there is no x, so it is independent from x, so no need of this x0. Then what is the solution of this kind of differential equation? You can easily find out using the linear differential equation. This is something a linear differential equation, but we are getting it using numerical solution. Now it is what? 0.2 into what is the value of t0? It is nothing but t0 is something 0. So it is basically, just let me check it. Yes. So it is h. What is h here? H is 0.2, and now it is 4 into 0 plus 4. This is 0.8. So what is k2? K2 is h, okay, f of t0 plus 1 by 2 into h, and x0 plus the previous one, k1 by 2. Similarly, k2 is nothing but h f f0 plus h by 2 and x0 plus k2 by 2, and at the end x3 is equals to, okay, k1 k2 k1, okay, k2 k3, and k4 is nothing but h f of x f of t0 plus h and x0 plus k3. So while calculating all these values, we are getting it as 0.88. It is at 0.88 again, and it is 0.96. So on putting all these values, we are getting k is equal to 0.88. Okay, after putting all these value in this case, so it will be yn plus 1 is y0 plus k, and this will represent the increment, or basically the calculated using Runge-Kutta, okay, increment in x, and this will be 0.88. okay, after finding all these value, we'll have this. So k will be 0.8. So this is the correct answer. Now next question is okay, so the next question is, yes, Newton-Raphson method is used to find the root of equation. This is the equation, and again the Newton-Raphson method is asking where initial guess is this. So the formula is xn plus 1 is equals to xn minus f of xn upon f dash of xn. So basically the function is given here, x cube minus 2x square plus 3x minus 1. Okay, oh yeah, it is plus. So f dash of x is nothing but 3x square plus 4 of x plus 3. So f at 1, okay, after second iteration, it is saying after second iteration. Okay, now here if I will put n is equals to 1 in this formula, so if n is equals to 0, sorry, So x1 is equals to x0 minus f of x0 divided by f dash of x0. It means x1 is equals to 1 minus, okay, x0 is my 1 here. So if I'm putting 1 plus 2 plus 3, so 5 plus 1, 6 minus 1, this will be 5, divided by this will be 4, 3, 10. So this will be 0.5. Okay. And again, if I will calculate, if I will put n is equals to 1, then it will be x2 and it will be x1 minus f of x1 divided by f dash of x1. And this is my x1. So 0.5 minus, on putting all these value, I will get 0.125. And on putting in this will be 5.15. It means it will be 0.3043. So this will be correct answer. So the correct answer is 0.3043 is the correct answer. Okay, the next will be this question. Using an unit step, the volume of integral. Oh, not volume. Basically, it should be the value of integral. The value of integral is something 1 to 2 and the function is x ln of x. So the function f of x is equals to x into ln of x, and here a is equals to 1, b is equals to 2 by trapezoidal rule. Again, if it is a trapezoidal rule and it is not defined what is the step size or what is the subinterval number, you can easily take these as 2. It means my x is equals to 1, so the function value is 0, and x is equals to 2, then function value is log of 2. Now we can easily find it is something called quadrature rule. We are taking 2 points only. So it is something 0 plus twice of log of 2. So it is something of something related to the value is log 2. Okay, the value of log 2 is something related, is called, okay, wait. Yes, it is basically 0.693. Okay, it is 0.693. Okay, now basically we'll go to next question, and next question is Simpson 1/3 rule is used to integrate the function between 0 to 1 using the least number of equal subinterval, the using the value of interval. So basically, while you are calculating the integration using Simpson 1/3, okay, the rule in Simpson 1/3 is that the minimum number of points are taken is 3. In trapezoidal, we have chosen 2. That is called quadrature formula. Now, if we will take 3 points, that will be the minimum number, in this case Simpson. Okay, the formula is basically a to b f of x dx, and in this case the formula is nothing but h by 3 y0 plus yn plus twice of all even number plus fourth of all odd number. Okay, so in this case at least 3 number we'll have to choose. So in this case my h is equals to 0 1, so 1 minus 0 by 3, it will be 1 by 3. Okay, so now while calculating the value, x is equals to 0. Okay, oh, is it 1 by 3? 3 points. Yes, it is 3 points. It means 2 subinterval. Sorry for that. At least 3 points. These are the points. It means y0, y1, y2. The n is 2. Okay, so it will be 0.5 and it will be 1. So the value, the function value at this point is 1.8, nothing but y0, 1.95 is y1, and 2.4 is y2. So it is what? 1 by 2 by 3, and it is 1.8 plus 2.4 plus 4 into 1.95. So the answer is 2. The correct answer is 2 for this problem. Again, next is basically here the value of function f of x 5 discrete point are below. Now using trapezoidal formula, then what is the value? Simply you can easily get the answer using the formula. The formula is basically for 0 to 0.4 f of x dx, all the values you will have. This is y0, y1, y2, y3 and y4. So you will put the formula as h by 4, Now you will have to calculate h. What is the h? In this case, it will be 0.4 minus 0 divided by 1, 2, 3, 4, 5. Okay, these are 5 points. So you will have to divide by 4. Okay, 5 points in it means n plus y n plus 1 is equals to 5, then it will be 4, then it will be 0.1. Okay, so next will be y0 plus y5 sorry y4 plus twice of all remaining y1 plus y2 plus y3. Now on putting all these value, we are getting the answer as 22. Okay, next will be related to system of linear equation. These are the equation, and in this case we are going to calculate it using the iteration method. So Gauss-Seidel method, basically the Gauss-Seidel method is used to solve the following equation as per the given order, assuming initial guess x1, x2, x3 as 0. It means I have x1 as 0, x2 at 0. This is representing the iteration number. Okay, x3 as 0. It is what the initial guess. So after first iteration, what is the value of x3? So it is asking. So basically for that we should have an value. We should have at least value of x1, x2, x3. But in this case, the main thing is here. If you are asking about x3, then easily start over here. So after the first iteration, just start over here. So you will get all these value. In this case, x3. What is x3? Then x3 is equals to, because of that it is just independent. We are solving using Gauss-Seidel method. In the Gauss-Seidel method, it is something. What is the value of x3? x3 is nothing but, you are using x1, x2. Wait, let me check it. Okay, if you will calculate x1 from equation number 1, then you will have 3. If I have 1, 2, 3, no? But for Gauss-Seidel method, we should at least follow the pivoting in this case. Because of that, if I will solve using, because it should be diagonally dominant, because the case of diagonally dominant will occur. It means all the values which is in the diagonal, the sum of the diagonal should be greater than. It means 1. Here 1 is not greater than like 2 plus 3. Okay, it is incorrect. So we'll have to make it diagonally dominant. So I will make it diagonally dominant. If I have these equation, then I can write it as, there is a mistake in this question. If I will write in the, okay, leave it. If I just want to find x3, then what is x3? X3 is nothing but 1 minus, okay, 1 minus 3x1 at 0 minus, okay, 2x2 at 0 by 1. So in this case, my x3 is equals to 1. Okay, accordingly you can find x2 and x3, or you can verify it. If it is not correct, you can verify it. If you will put all these values, you will get all values. Okay, you can easily verify it. Or either there may be problem in this question, or the data is wrong, because according to the answer it is not correct. Okay, anyway, let's move to the next question. Next question is solve the equation x is equals to tan cos of x, again using Newton-Raphson method, at using the initial guess x is equals to pi by 4. Here the initial guess is again in the radian, so no need of the problem. So up to second decimal places you will have to correct it. So my f of x is equals to this, then f dash of x is nothing but, f dash of x will be, okay, wait, x minus this. So f of x, this will be x is equals to tan cos of x. So the f of x will be x minus tan cos of x. So the f dash of x is basically 1 plus tan sine of x. Now you can start over here. Xn plus 1 is equals to xn minus f of xn divided by f dash of xn. So this is basically pi by 4 plus or you can write it as pi by 4 minus, Okay, pi by 4 minus the function is basically pi by 4 minus tan cos of pi by 4 divided by 1 plus tan sine of pi by 4. So after getting it 1.5639 up to second decimal places, if you will calculate next one, it will be 5.6 something. So it will be 1.56. The answer is 1.56 for this problem. Next question is again in mechanical engineering. The root of the function is basically f of x is equals to x cube plus x minus 1 obtained after the first iteration on application on Newton-Raphson scheme using x0 is equals to 1. Again, starting over here. So what is the f dash of x in this case? So f dash of x is basically 3x plus 1. So we are calculating it easily. Oh, again, I think it is a repeated question. We have also solved. The answer is okay. It is not repeated. Okay, yes, that's the another question. Easily, we can easily find x1 is equals to x0 minus f of x0 upon f dash of x0. It is nothing but 1 minus 1 by 4. 1 minus 0.25 is related to 0.750. So it will be 0.750 will be the answer. We'll have to put all these data in these functions. Okay, the next question is related to. Wait. Next question is related to numerical integration. The numerical integration using trapezoidal rule gives the best result at a single variable function. Obviously, if y is equals to f of x is there, then I just told in the previous question that the order of numerical schemes is basically linear for trapezoidal. So the linear polynomial will be the best correct accuracy for the trapezoidal. If you are calculating from the trapezoidal formula, then on linear polynomial or the first order degree polynomial or equation of line, it will give the best result on minimum number of points. Okay, so the next question is something related to again integration. It is related to trapezoidal. Now your function f of x. Okay, now your function f of x is sine of x plus cos of x. Okay, and a is equals to 0, b is equals to pi. So the error is numerically computed in the integral this 0 to pi sine of x plus cos of x dx using the trapezoidal rule with 3 interval of equal length between 0 to h is. So basically they are asking about the error. So how will we calculate error? We'll just find error, we'll just find numerical solution and exact solution, and after that we'll just compare it on 3 number of intervals. So here we will like they have given as the 3 number of interval. It means like my n is equals to, in this case n is equals to 4 will be there. Okay, so basically 3 number of interval, it means 0 to pi. Okay, 3 number of intervals, so it will be 1 2 3 3 interval, so it will be pi by 3 and it will be 2 pi by 3. So the values of the function are basically by calculating using trapezoidal. So the numerical solution, so the numerical solution is something like this: h by 2 y0 plus y3 plus twice of y0 plus y1 plus y2 plus y3 and twice of y1 plus y2. Okay, so I is nothing but, what is your h? H is pi by 3 by 2, and you are calculating the value and after finding y0. So what is the y0 in this case? Okay, I'm just writing here. Y0 is 1 plus y3, again on pi it is minus 1. Okay, plus twice of y1 on pi by 3 it is 1.366 and it is 0.366. So the value calculated by numerical method or trapezoidal, it will be 1.1812. Okay, 1.1812. Now we'll just integrate using ordinary method, that will be I1 or basically I2 and it will be I1. Okay, then it is sine of x plus integration of 0 to pi. Okay, we can separate it easily, and if I will find, so the integration of sine x is nothing but minus of cos of x from 0 to pi, and it will be sine x 0 to pi. So the formula here, it is basically, if I will calculate from 0 to pi, it will not give me the like exact solution. I will have to break, because of that there is a singularity in this case. Okay, so here you will have to find, or you will have to calculate the integration in this way. It will give the wrong answer. Okay, if you have any kind of integration like sin x plus cos of x dx, then you will have to write it as 0 to pi by 2 sin of x plus cos of x dx, and again from pi by 2 to pi sin of x plus cos of x dx. Now it will give the correct answer. Okay, so this will be 1 plus 1 minus 1, or 1 minus 1 plus 1 minus 1, it will be 2. So if it is 2 and it is 1.182, it is not correct. So the error will be I1 minus I2, or we can say that the mode of error is nothing but 1.8, or basically 1.1812 minus 2 is nothing but the mod is basically 0.1817. Okay, so the answer is 0.187, not 17, 0.187. So this is the correct answer, or the error in this case. Okay, so next we have to calculate the integration p0 comma 3, q 0.5 comma 4, and r1 comma 5 are 3 point on the curve defined by function f of x. Numerical integration is carried out using both trapezoidal rule and Simpson rule within the limit x0 to 1 on the curve, the difference between the result. Okay, first you will have to calculate using numerical, using trapezoidal, and then we'll calculate it using Simpsons. So by using trapezoidal, okay, so we are 3 point, what 3 0, the value at of the function at 0 is 3, and the value at 0.5 is 4, and the value at 1 is 5. Okay, simple. First case, okay, here h is 0.5, so it will be 0.5 by 2 using trapezoidal, so it will be y0, or basically we will just write y0 is 3 plus last is 5 plus twice of 4. Then this is nothing but the value you using calculated. We are just calculating it as 0.5 by 2. Okay, just wait. Okay, just let me check another one. If it is the same expression, then it will be 0. It may be 0. So now by Simpson's method. So the Simpson's method is basically something related to like this, 0.5 by 3. Okay, and now it is what, 3 plus basically y0 plus first plus last, and 4 into 4. Okay, now these all work, because if I will take it as like this, if I will take the difference from this, so it will be 0 after calculating. Now here it is 8 plus 8, and it is also 8 plus 8. By calculating it, we can say that the solution, okay, let me calculate it. If I don't think so it is 8 plus 8, because 3 plus 5 is 8. Okay, 8 plus 8, and it is 16. Okay, it is 16 16 plus 8. Okay, it is 16 plus 8, 24 by 3 into 0.5. So now it is 24 by 3 into 0.5, 6.4, and it is also 6.4, just double. So the correct answer is 0 here. Okay, next. So the main important practice is that you should have an idea about the formula and the trick, and main important thing is that the calculation. Okay, the efficiency in the calculation basically. Next question is, an explicit forward Euler method is used to numerically integrate the differential equation. It is just simple numerical It is a simple the solution of differential equation. Okay, step size is this. So my differential equation dy by dt is y, and step size is 0.1. Initial value condition is given as y0 at 1, and I just want to calculate y1. Now, up to 2 decimal places. This is what the important. Okay, let's start. What is the formula for Euler? That is n plus 1 is equals to yn plus h into f of t comma y. Yes. Now my function is here y only. Okay. So y1 on putting 0, it is y1. y1 is something y0 plus h, and the function is y. Okay. Or basically t0, y0, and it is y0. Now it is what? 1 plus 0.1 into 1, it is 1.1. So now my y1 is 1.1. Again, I will calculate y2. I will put n is equals to 1. Then it is y1 plus h into f of t0. Oh, sorry, t1. And now it is y1. My function is only y. And I will just write it as y2 is equals to 1.1 plus 0.1 into 1.1. And the resultant is 1.21. Now, 2 decimal places are not correct. I will just calculate n is putting n is equals to 2, y3 is equals to y2 plus hf of t2 y2. It means that 1.21 plus 0.1 into 1.21. Now it is something 1.331. Still it is not correct. Okay, after doing 10 iteration on putting n is equals to 9, you will have y10, and the value is basically 2.5937, and y1 will be 2.59 something. So here the 2 decimal places are correct. It means your answer is 2.59. You can easily write it here. Next is related to electronics and communication engineering. So basically, here we have match list first and list second, and select the correct answer using the codes given below the list. Okay, Newton-Raphson method. Okay, A is something related to what? Newton-Raphson method. Newton-Raphson method is for solving non-linear equation, though this is first one. Okay, next one is Runge-Kutta method. Runge-Kutta method is solving ordinary differential equation. So it will be 3. Simpson's 1 by 3, it is numerical integration, and last one will be interpolation. Gauss elimination is related to interpolation. Is something that, okay. It is wrong answer. It is not related to interpolation. It is solution of system of linear differential equation. Not linear differential, linear system of linear equation. Okay. So here, according to the most correct option is the C is correct. Okay. A is related to 1, B is related to 3, C is related to 4, and calculating eigenvalues, numerical solving. Okay, this is what not question is not wrong. This is what the given here. Solution like solving simultaneous linear differential equation is here. Okay, this is not, it is not related to interpolation. This is related to, okay, I just thought that there are 4 point only. There are 6 point. Okay, yes, next. So the C answer is the correct answer. Next one is electronics and communication engineering. Question is, the equation is given in this case. Solve using Newton-Raphson method. My function is nothing but x cube minus x square minus 4x minus, 4x plus 4x minus 4 is equals to 0. Is to be solved using the Newton-Raphson method if x is 0 is equals to 2 is taken as the initial approximation of the solution, then the next approximation using the method will be. So in this case, f dash of x will be 3x square minus 2x plus 4. So xn plus 1 is equals to xn minus f of xn divided by f dash of xn is nothing but x1 is equals to x0 minus f of x2 upon f dash of 2. So the values are as follow: 2 minus 8 by 12, then 4 by 3 will be the correct answer. So the second option will be the correct one. Next question is related to the recurrence relation of to solve x is equals to e to the power minus x of the Newton-Raphson. So basically, if you are putting this function to Newton-Raphson formula, xn plus 1 is equals to xn minus f of xn divided by f dash of xn, then it will be what? So x minus e to the power minus x is nothing but my f of x. So the f dash of x is what? 1 minus plus, okay, e to the power of minus x. Then it will be what? Xn minus x minus e to the power minus of x divided by 1 plus e to the power minus of x, or basically xn. So here, after simplifying this, we can easily write it as x into 1 plus e to the power minus of xn minus x plus e to the power minus of xn divided by 1 plus e to the power minus of xn. So after writing this, we can write it as x and x will be get cancelled. Then if you will take e to the power minus x common, then it will be x plus 1 or xn plus 1 e to the power minus xn divided by 1 plus e to the power minus xn. So it is, okay, C answer is the correct answer. Next. So next one is related to differential equation. This is a linear differential equation basically. Now calculating it using, consider the differential equation using Euler's first order method. Find the value of y03. Okay, the differential equation is dy by dx minus y is equals to x, and the initial condition is given as y0 is equals to 0, and the step size h is 0.1. So the Euler method is yi plus 1, or basically yn plus 1 if you are writing n. From starting I am writing n. So yin plus 1 is equals to yn plus h into f of xn yn. Now your function f of x, this is nothing but dy by dx is equals to x plus y. So this will be your f of x comma y. So in this case, your n is equals to 0, then y1 is equals to y0 plus h f of x0 y0, then it will be 0 plus, because what is the meaning of y0 is equals to 0? It means my x0 is equals to 0, this one is x0 and this one is y0 is nothing but 0, and h is 0.1. This is what? x0 plus y0, then it is 1 plus 0, so my y1 is equals to 1. Okay, so the y1 is equals to, because okay, x0 is also 0, no? So y1 is equals to 0. Okay, now this is what y at okay, yeah, it is y1 is equals to 0. Now I'm putting n is equals to 1, this will be y0. Now here my x0 is equals to 0, then x1 is equals to x0 plus h, the next one. This will be y1 plus h of f of x1 y1 will be there. Then y2 is equals to, what is y1? y1 is 0 plus h is 0.1. Then x1 will be 1, 0.1 plus y1 is 0. Now it will be 0.01 here. So it will be y2, and on putting y is equals to, okay, it will be y 0.2 and it will be y 0.1. Okay, now I will find y 0.3. That will be y3 is equals to y2 plus h f of x2 y2. So y3 is equals to, what is the y2? It is 0.01 plus 0.1, and it is x. What is my x3? Oh, sorry, x2 is nothing but x1 plus h. x1 is 0.1. So 0.1 plus 0.1, it is 0.2. So it is 0.2 plus 0.01. So it is nothing but 0.031. So the correct answer is 0.031. Okay, next is a numerical solution of the equation can be obtained using Newton-Raphson method if the starting value is x is equals to 2 for the iteration the value of x is to be used in the next step. So what is the value of x? It means what is the next value of x. Okay, so my function f of x is given x plus root of x minus 3. It is a transcendental equation. Now the formula is xn plus 1 is equals to xn minus f of xn divided by f dash of xn. So what is the formula of f dash of xn? It means, so what is the value of f dash of xn? It means the derivative of function. It is nothing but 1 plus 1 upon 2 root of x. Okay, so my x0 is equals to 2. So x1 is equals to x0 minus f of x0 at f dash of x0, and then x1 is equals to 1.694. So it will be C option is the correct option. Next question is related to matching. So P1 is numerical integration and M1, okay. P1 is numerical integration. So what is numerical integration? Simpson 1 by 3 is the numerical integration. So P1, okay, P1 matching to M3. Now P2 is the solution of transcendental equation is Newton-Raphson method. So P2 matching with M of 1, and next one will be the next one will be the, sorry, this is the solution of transcendental equation, and the solution of system of linear equation is the method. Okay, Gauss elimination method is the solution of system of differential equation method. Okay, and last one with the differential equation, and the Runge-Kutta method is the solution. Runge-Kutta is the method to solve differential equation. So it is M2. So P1 is equals to M3. Okay, so this is not correct. So P1 is equals to M3. Okay, P2 is equals to M1. So this will be not correct. So B option is the correct option. Next. So the Newton-Raphson method is used to solve the differential equation again and again. These are the question only. To find f of x is x cube minus 5x square plus 6x minus 8 is equals to use this, and f dash of x is equals to 3x square minus 10x plus 6. Now you can easily take it as x0 is equals to 5, and you can find x1, and that will be 4.2903. You can easily calculate it using the formula. Next I have next I have the differential equation. This is what dy by dx is equals to minus 3x plus 2, and the initial value is given as, okay, not dy by dx, it is dx by dt. So dx by dt is this, and it is x0 is equals to 1. It means t0 is equals to at t is equals to 0, my x0 is equals to 1. Now solve using a Euler method. The largest time step taken as largest time step, what we can take. So now here the meaning is that what is the largest time step. So in this case, while solving Euler's method, so if mod of 1 minus 3 of h, it means this will be the f of x. So this f of x is like something less than 1. Okay, it is what the largest step size. Okay, so what will be the largest step size in this case? So it will be unstable. The numerical solution will be unstable. So if my function or the derivative or the first derivative of the function, if it is not less than, what is the stability condition of differential equation? If you will have y dy by dx is equals to f of x comma y, then mod of or the partial derivative of f and like with respect to x, it should be less than equals to 1. This is the stability condition. If my h will be greater than this value, if my like partial derivative will be greater than 1, okay, it means will be greater than 1, yes, then it will be unstable. So it is function, it is what the value, and I can put as x is equals to h, it should less than 1. Okay, now in this case I can just remove like this, I can subtract 1 from this. So if I will write if I will remove the mod, then it will be minus 1 less than 1 minus 3h less than 1. If I will subtract 1 from each, so I can write 1 minus 1 less than, it is minus 3h less than 0. If I will divide by 3, so it will minus 2 by 3, divide by minus 3 basically. So it will be 2 by 3 less than h less than 0. So it is something like this, 0 less than h less than 2 by 3. So if my h is less than 2 by 3, then it will be stable. if it is greater than or equals to this 2 by 3, then what is the possible value at where the solution is unstable? So it is 2 by 3, it means 0.66. So this is what the important condition here. Okay, next. Consider the first order initial value problem. Okay, 0, x is from 0 to infinite. The exact solution is this: x is equals to 0. For x is equals to 0.1, the percentage difference, or basically the percentage error, is going to calculate in a single iteration for the second order Runge-Kutta method. Using second order Runge-Kutta method, so it is what the RK second order. So first of all, what is the formula for RK second order? So if you are going to calculate solution by Runge-Kutta method, then it is nothing but yn plus 1 is equals to yn plus f of plus k. Now in this case, what is k? Now k is nothing but some 1 by 2 k1 plus k2. So what is k1 here? So k1, what is the differential equation? Y dash is equals to y plus 2x minus x square. This is my f of x, and the initial condition is given as y0 is equals to 1. It means x0 is equals to 0 and y0 is equals to 1 here. So my k1 is equals to h into f of x0 y0. Then it is what is h here? So h is given as 0.1. This is 0.1. If I will put these values 0 and 1 in this function, then I will get k1 as 0.1. Similarly, what is k2? K2 is nothing but h into f of x0 plus h and y0 plus k1. Okay, then this will be 0.1. If I am putting all these values from the given data, then it will be 0.129. Now I have k1, k2, I can find k. So k is equals to 1 by 2, 0.1 plus 0.129. Then the value of k is nothing but 0. Yes, it will be 0.1145. Okay. Then what is y? If my n is equals to 0, then y1 is equals to y0 plus k. Then it is y0 is 1 plus 0.1145. Then this will be 1.1145. So this will be the numerical answer. Now, if the exact solution is given as yx is equals to x square plus e to the power x. Now, what is the solution at this? What is x here? Now, x0 is equals to 0. Then x1, what is x1? X1 is 0.1 because 0 plus 0.1, which is my h0, like x0 plus h. That is what the 0.1. So it is what 0.1 square plus e to the power 0.1. Then the value is something like 1.1152. Now you will have to calculate the error. So the error is nothing but y exact minus y numerical. So this is what 0.1, sorry, 1 point. This is 1.1152 minus 1.1145. Then it is what 0.00069, something like this. So what is this? This is 0.06 percentage. So this is 0.06% error is there using this h and using basically in the single step only. Okay, next question is starting with x is equals to 0, x is equals to 1. Okay, starting with x is equals to 1. After two iteration, Newton-Raphson method for f of x is equals to x cube plus x is equals to 1. So my f of x is equals to 1 minus x cube minus x. Then f dash of x is equals to 1 minus 3x square minus 1. Or basically it will be, sorry. It will be like this. Yes, it will be 0 minus 3x square minus 1. Yes, this is my f dash of x, and using this formula xn plus 1 is equals to xn minus f of xn f dash of xn. So the final value in this case after on putting n is equals to 0 and n is equals to 1, after that we are getting x2 is equals to 0.686. So 0.686 is the correct answer. Next, consider p of s as a function. This is what the p of s is given, s cube plus a2 s square plus a1 s plus a0. With all real coefficient, it is known that its derivative p dash of s has no real root. So it is 3s square plus twice of a2s plus a1 has no real root. Okay, then the number of real root of ps. Okay, there is a concept, there is a simple concept behind this. If any function has r real root, then its derivative has one lesser number of real root. It means p dash of has r minus 1 number of real roots. Okay, so it means it has 3. If it is has 3 real number of root, then what is this? It is r minus 1. It is known for that has no real root, then the number of real root of ps. Okay, if my p dash of s has no real root, okay, this is what r minus 1. Now r minus 1 is equals to 0. So r is equals to 1. It means p of s has one root. Okay, r minus 1 is the number of root of p double dash, p dash of s. Now if it is 0, then what is r? R is the root of ps. So it is 1. This is a simple concept. Next, the Newton-Raphson algorithm for a function will be, so these are the functions. So what is the Newton-Raphson algorithm for any function? So basically, to calculate any kind of numerical analysis or any kind of formula in the numerical or basically in the Newton-Raphson method, we will just take as any type of root. Let's say this is 1 by 2 ak function will be. Okay, see, one thing is there, a is there, and a is in, basically a is always in numerator here. So just let's start with x is equals to 1 by a. So this will be 1 by x is equals to a, then 1 by x minus a is equals to 0 will be the equation. If you will find the numeric Newton-Raphson scheme for this, you can easily get. So how will we proceed? So my f of x is nothing but 1 by x minus a. Okay, so what is the f dash of x? It will be minus 1 upon x square. Okay, then xn plus 1 is nothing but xn minus f of xn and f dash of xn. On putting all these values, you will find out this will be the numerical scheme of Newton-Raphson method for this equation. Next one will be for a is equals to 7 and starting with x0 is equals to 0.2, the iteration will be for what? Question is incorrect here. This is the mistake in this question. Okay, let's start with the next question. So next question is that a second degree polynomial, if f of x has, okay, a second degree polynomial function f of x of 1, 4 and 15 at x is equals to 0, 1 and 2. These are the value. It means x is equals to 0, f of x are, the value has 1, at 1 it is 4, at 2 it is 15. Okay, now what it's saying, it is saying about the estimated or dx is 0 to 2, f of x dx is to be estimated by applying the trapezoidal rule to the data. What is the error defined as true value minus approximation value? Okay, in the, okay, just you have to find the, you will calculate the numerical result and exact result. Then what is the solution basically? So first of all, you should have what is basically the numerical. Okay, first of all, what is the polynomial? Because of that, we should have f of x to find exact value. So how will we calculate? Okay, trapezoidal formula you can easily calculate. The integration value I will just write directly. It is numerical in. It will be just easily calculated from the numerical formula. That is nothing but you have seen it is the like 3 formula, then h by 2 y0 plus yn or y3 plus twice of y or y2 and twice of y1. This will be formula, and the numerical result will be 32.3. This is the numerical. Now, okay, yes, not 32 point, sorry, it is 12 point, it is 12. Calculating is using 12. Now, what is the polynomial? The point is that how can we find the polynomial? Because to find exact solution, we should have at least one polynomial. Because of that, what is the f of x? Because without f of x, we can't proceed to exact solution. So for that, I will just consider, because of that, it is a 3 point. If it is a 3 point, then I can consider it as a second order degree polynomial. And it is, obviously it is given that second order degree polynomial is here. So I will just, as okay, not using these data, I can't guess, but it is given that second order polynomial is there. Okay, what is the general form of second order polynomial? X0 plus x1 of x and x2 of x square is here. Now you can find, if my f of 0 is equals to 1, it means what? My a0 plus a1 into 0 plus a2 into 0 square is equals to 1, then a1 is equals to 1. Okay. Now I can find if my, sorry, not a1, a0. So if my a0 is 1, then I will write it as my function f of x is equals to 1 plus a1x plus a2x square. If I will put 1, then I will get 4. It means 1 plus a1x, or basically 4 on, sorry, not 4, x is 4, 1. Okay. And plus a2, it is what? 1 square. So it is 4. So a1 plus a2 is equals to 3. This is equation number 1. And again, if I will put 2 in f, I will put 2, then I will get 15. Then it will be 1 plus a1 of 15, a1 of 2 plus a2 of 2 square is equals to 15. Then the next equation will be twice of a1 plus 4a2 is equals to 14. This is equation number 2. Using these both equation, I can calculate a1 and a2. So what is the value of a1? Here a1 is equals to minus 1 and a2 is equals to 4. Using these both equation, I can find. So the function is nothing but 1 minus x plus 4x square. This is my function, and I can easily calculate the integration of this function 0 to 2 dx, and it will be 32 by 3. Now, what is the error? So the error is 32 by 3 minus 12, and it is something minus 4 by 3. Okay, so this is okay. Here, why it is minus 4 by 3? If there is an option 4 by 3, then we can't correct that. Because of that, they have defined the formula, that is true value minus approximate value. There is no mod here. Okay, so keep in your mind these things. Next, this is again in civil engineering, the differential equation. This is what related to backward implicit Euler formula, simple as like this. Then what is the backward implicit simple like formula? So in this case, we can easily implicit formula. So we can just write it as like this: dy by dx is equals to 0.25. It is the equation given. Then h is equals to 1 here. Y0 is equals to 1. It means at x is equals to 0, the y value is 1. Iterative equation by backward Euler. So basically the backward Euler's method is something like that: yn plus 1 is equals to yn plus h f of xn plus 1 comma yn plus 1. Now in this case, yn plus 1 is equals to yn plus h into function is something 0.25. Now h is 1, okay, and x, or it is yn plus 1. So it is yn plus 1 whole square. I don't have any yn plus 1. Because of that, it is what? Euler implicit. Now I will just, I can just write it as here. So it is 0.25 yn plus 1 square minus yn plus 1 plus yn is equals to 0. This will be equation. Now what is this? It is just a non-linear kind of equation. It is a non-linear kind of equation. I can find the root using Newton-Raphson method. Okay, so I will just write it as 0.25 y1 square minus y1 plus y1 is equals to 0, y1 square. Now it is what? Wait, it is not y1. It is okay. Y0. If I am putting n is equals to 0, then it will be n is equals to 0, and then y0, and y0 is 1 here. Is defined. So this is my equation. I will just find y1. So what is y1? Then 1 plus minus 1, 1 minus 1 divided by 2 into 0.25. Using Sridharacharya method, you can easily calculate. So my y1 is equals to 2. So it is C. So basically this is what we can get. This is the formula of Euler backward formula. And after that, you are applying the quadratic like method or root finding of quadratic equation. Okay. Next one. Next one is the given that one root of the equation. Okay. So this is one root. Then what are the other root? You have to calculate. You can easily calculate. If you have x cube minus 10 of x square plus 31 of x minus 30, and if it is if we will divide, if it is a root, then x is equals to 5, then x minus 5, and it is what? X minus 1. This is just a thing to do in the 9th class. I will not going to answer it. Or even you can easily put, you can verify it. If you will put 2 and 3, or basically if you will put all these values, then it should be 0. It should satisfy. It means no need of dividing this. Just use a sort trick. And the sort trick here is something that it means if it is, if that is a solution, then that should satisfy the equation. Okay, just let's start. Let's try with the 2 and 3. So with 2 it is 8 minus 10 into 4 plus 31 into 2 minus 30. It is what? 8 minus 40 plus 62 minus 30. It is what? 70 minus 70 is 0. Okay, 2 is satisfying. Now 3. So it is 27 minus, okay, 90, okay, plus 93 minus 30. Now see, what is this? It is again 100. It is 100. This pair is satisfying. These are the another root of the equation. No need to divide and all. Okay, next you will have simple. This is the equation, and what is the Euler, what is the Newton-Raphson scheme for this? Okay, for kth iteration, it means the formula is what? K plus nk plus 1 is equals to x of k, xk plus 1 is equals to x of k minus f of x at k divided by f dash of at k. Now your equation is f of x is nothing but x cube minus 4 of x minus 9, and the f dash of x is nothing but 3x square minus 4. Now if we'll put this one here, so x of k minus 3, x cube at k minus 4x at k, it is plus minus 9 divided by 3x square at k plus 4. And if you will simplify it, you will get this is the correct answer. Okay, next. So the next question is the minimum number of equal length subinterval needed to approximate the integration 1 to 2 x e to the power x dx. Okay, so what is the minimum equal length subinterval? So the equal length subinterval is something at least, this is what, at least 1 by 3 into 10 to the power minus 6. This is the accuracy using the trapezoidal rule. Now what is the interval length you will find? How will you find interval length? N number of n, b minus a divided by h. What is h? How will you calculate h? So we can easily find h using that word. So basically, to calculate n here, or to find this value, we will have the formula h cube by 12 into maximum of triple integration at n is I into n. Now we have function c, f of x is equals to x e to the power x. Okay, f dash of x is what? X e to the power x plus e to the power x. Okay, f double dash of x is nothing but x e to the power x plus e to the power x plus e to the power x. It is nothing but e to the power x, x plus 1. It is nothing but e to the power x, x plus 2. So these are the value, and since both e to the power x and x are increasing function, okay, these both are increasing function, and maximum value are like taking, let's say it is my maximum value in the interval of any point xi is 2. So at by occurrence xi at 2. So let's say the maximum value occurs at xi is equals to 2. So on finding the value, just we can find what is my n, b minus a divided by h. So on putting this n here in this formula, so I will just find the error. I will just find the bound of the truncation error. That is what the h cube upon 12, and the maximum value of this. That is what b the function maximum value 4 e to the power 2, and this is b minus a 2 by 1 or 2 minus 1. So after calculating all these value, it will be 1 by 3 into 10 to the power 6, where h is what? Now putting this value. So this is what? Given data. Now I will put this error as like this. I will compare it as h square by 3 e square. Now what is my h square? It is 10 power minus 6 e square. Then h is what? 10 to the power minus 3 by e. If I will put this h is here, then I will get n is equals to 10,000 into, sorry, 1000 into e. So this a is the correct answer in this case. Next question is related to Simpson integration. You have data y0, y1, y2, y3, y4. What is the formula in this case? So the I is equals to h by 3 y0 plus y4 plus twice of all even number y2. Okay, only y2 will be there. Okay, 4 into y1 plus y3, odd number will be there. On putting the value, the answer will be 0.7854. A is the correct answer. Next question is if x square minus n is equals to 0, the square root of a number n is, okay, yeah, x is equals to root of n, then this equation can be derived using this. Then if I denotes the iteration index, then the correct iterative scheme. Okay, then fi xi plus 1 is equals to xi minus f of xi divided by f dash of xi. So it is nothing but xi minus xi square minus n divided by twice of xi. So it is what? Xi square, in this case xi square, and minus of this. So it will be 2xi of square minus xi of square. It is xi of square plus of n divided by 2 of xi. So it will be 1 by 2 and xi plus n divided by xi. So the correct answer is D. Sorry, B. So the correct answer is, sorry, not B. The correct answer is A. So next question is related to Simpson 1 by 3. Again, you will have 0.5. It is 1.5 and the function is 1 by x dx. The rule with 3 point. Now, after that, what is it? So basically, the estimated obtained using Simpson rule with 3 point function evaluated exceed the exact value by. So basically, this is what the integration. So the estimated exceed exact value will be given by this. So first of all, you will calculate the numerical solution at the 3 points. It means x is equals to 0.5, x is equals to 1, and x is 0, 1, and 2. It is 1.5. Okay, you will find 1 upon 0.5. It is 1, and it is 1 upon 1.5. So you are getting, you are calculate by using Simpson 1 by 3, h by 3, y0 plus y2 plus 4 into y1. So the numerical value will be 1.111. Now the exact solution 0.5, 1 by 5, 1 by x dx. Exact integration is nothing but log of x 0.5 to 1.5. It will be 1.0986. So the error is 0.012. So the D answer is the correct answer. Next question is related to the error in d by dx for a continuous function with h is equals to 0.03 using the central difference formula. This is related to finite difference operators or finite difference method. Okay, So the central difference formula is this. It is nothing but d of by dx, something f of x. So it is f of x0 plus h and f of x0 minus h divided by twice of h. So this is the error, and x0 and f of x0 are this. This is the value at x0 is equals to 19.78, f of x0 is 500.01. The corresponding error in the central difference estimate for h. Okay, so basically error in the central difference is order of, because this is a central difference, so it is nothing but a Taylor series truncation of order 2. So the order of this scheme is 2. So if it is order is 2, then if my h is equals to 0.03, then it will be 2 into 10 to the power minus 3. Okay, so it is given. So the error at h is equals to 0.02. It's approximately 2 into 10 to the power minus 3 into 0.02 whole square upon 0.03 square. It is nothing but 9 into 10 to the power minus 4. It is basically the order of 2. So it is what? The correct answer. So D is the correct answer here. Next question. The magnitude of the error is calculated, corrected up to 2 decimal places is in the estimated following integral using Simpson 1 by 3. So first of all, we'll just calculate the numerical result using Simpson 1 by 3 at with the length x is equals to 0. It means x0 is equals to 0, x1 is equals to 1, x2 is equals to 2, x3 is equals to 3, and x4 is equals to 4 will be there. And after that, you will find the value and you will find the integration as h by 3. Then y0 plus y4 is there, and 4 into odd y1 plus y3 twice into even. There is no even. Okay, so it's 0. Then the I value is here from 0. Okay, h is equals to 1 here. Then the integration is 245.33. And after calculating 0.0 to 4 x power 4 plus 10 dx, it is nothing but x power 5 by 5 plus 10 into x. From 0 to 4, it is nothing but 244.8. Now, after subtracting this value from this, we'll get the error, that is 0.53. So the 0.53 is the error in this method. Next, here the integral form is something like this. This is basically the integral form. X1 is equals to x1 to 2 and x square dx, where x2 is greater than x1 is greater than 0 is evaluated analytically as well as numerically, okay, using a single application of the trapezoidal. Okay, using trapezoidal we are calculating it. Okay, if I is the exact value of the integral obtained using analytically and j is the approximate value using the trapezoidal. Okay, j is numerical value and I is theoretical value. Okay, it is numerical and it is approximated, or basically we can say exact value. Which of the following statement is correct? Which value will be larger than? So first of all, what is the significance of trapezoidal formula, or basically calculating using 2 points only? There is no intermediate point. See, what is this x square? Okay, what is x square here? X square is nothing but a quadratic form. So wait. Okay, it is y-axis, it is x-axis, and it is what? The x square. Here it is x1. x1 is here and x2 is greater than this. So it is my x1 and it is my x2. Okay. Now, analytically, it will get like this. So this will be the weight. Analytically, the integration is this one. Okay. So the I value will refers to this. But this is nothing but simple line joining through this. So this is simply this. So which one is greater? Now, this is the remaining part which is calculated in numerical method also. So which value will be larger? Obviously, A will be the correct answer. So this is the simple concept of this. Okay, otherwise you can see using error, this is h cube by 12 and f double dash of xi into n. You can easily calculate from this, but no need of this. Just using the basically mind, just we are getting it as using shortcut trick. Okay, next. Newton-Raphson method is to be find root of some f of x is equals to 3x minus e to the power x plus sine of x. Initial root is equals to x0 is equals to 0.333 is taken. You will just find f dash of x is 3 minus e to the power x minus of, sorry, plus cos of x. And just put in the formula, you will get the answer is x1 is equals to 0.36. Next. Consider the equation du by dt is 3t square plus 1 at u0, with u0 is equals to 0. It means at t is equals to 0, you have the value u is equals to 0. Forward Euler method you are applying. Delta t is equals to 2. It means h is equals to 2. Easily you can find yi plus 1 is equals to yi plus h into f of xi. Yi, this is the formula. After putting all these value, you are getting the solution is 2 at 1. This is what the simple numerical scheme after putting all these value in this case. Now, what is the, this is like saying that what is the absolute error? So it is du by dt is equals to 3t square plus 1. So you will have to find the analytical solution. So it is du is equals to, it is just a variable separation method. You will just write it as here on integrating both sides. It is u is equals to, it is what, 3t cube by 3 plus t. And now, and plus c is also there. So it is u is equals to t cube plus t plus c is there. Now, at t is equals to 0, u is equals to 0. It means 0 is equals to 0 cube plus 0 plus c, then c is equals to 0. It is what, u is equals to t square plus t is the answer. Now here, what is t here? Here t is 0. Here t is 2. Okay, so if I will put 2 here, then I will get the solution. Okay, so in this case, okay, yeah, it is cube, na? Okay, so at t is equals to 2, the value is 2, and here at t is equals to 2, the value is 8 plus 2 is 10. So 10 minus 2. So the error is 8 here. This is what the simple concept, approximated solution minus numerical solution. Next one will be the same question as related to Newton-Raphson method. You can easily find it. Skip this. If it is new question, then I will do it. The differential equation, okay, this is the differential equation, dx by dt is equals to 1 minus x upon t. Okay, it is t or tau related, something like this. It is tau. So it will be considered as, wait, it is tau. Now, it is discretized using Euler numerical integration, okay, method, and basically delta t is 0 greater than 0. What is the maximum possible value of delta t to ensure the stability? That's the simple concept. In the case that we have already seen the maximum concept, what is the case? This is what, 1 minus x by tau. Okay, so in this case we can find what is h here. So in the form of h, we are just finding the numerical scheme yi plus 1 yi plus h into f of xi and yi. Okay, so here it will be x in the form of x. Okay, so because the independent variable, this is what, this is independent variable, this is independent variable, and this is the dependent variable. So we are finding the value of x, so it will be xi plus 1 is equals to xi plus h into f of xi and ti. Now here we are finding it as xi plus 1 is equals to xi plus h. What is the function? Function is 1 minus xi by tau. Okay, then what is xi plus 1 is equals to 1 minus, we can rearrange it like this, h by tau into xi by multiplying this, and plus h upon tau. Okay, now here what is this? This is just a form, and we are taking it as a simple this form. Now it is my function. If I will differentiate partially, if it is my f, and what is the stability condition? Dou f by dou x should less than equals to 1, or not equals to 1, less than 1. And now in this case, this will be 1 minus. If I will differentiate, if I will partially differentiate this function, the differentiation of x is 1. So it will be 1 minus h by tau less than 1. Now what is the value of h? If I will like write just as like this, if it is a mod, then it will be minus of 1. Okay, wait. It will be minus of 1 less than 1, 1 minus h upon tau less than 1. So if I will subtract 1, so it will be minus 2. Okay, then less than minus h by tau less than 1 or 0. So it will be 0 less than h less than 2 tau, 2 into tau. So what is the maximum possible value? That is twice of tau. Okay, so this is the where at which the discretized scheme will be unstable. Next, numerical integration. Yes, Newton-Raphson method. You can do it. Next one. This one is also Newton-Raphson method, and the scheme just using this formula: xn plus 1 is equals to xn minus f of xn f dash of xn. Easily you can find the solution of this is A. This is the solution. Okay, next question is related to, yes, this one is something like that. If it is a matrix A and it is a form in the form of L into U, you can easily multiply this one and this one. You can easily multiply by verifying sort trick. If you are not multiplying, then you use the Doolittle formula. What is the Doolittle discretization? If it is 2, 1, 4, minus 1, and the lower will be 1, 1. Okay, there are two approaches to solve it, Doolittle, and another one is something like that. If I'm not getting, actually I'm not remembering the name of that scheme. Basically it is Doolittle scheme, or otherwise you can just multiply and you will get this scheme. Okay, no problem. Doolittle and Court method. Yeah, Doolittle and Court, there are two schemes. That is what this is what L21. I say this is my x1. This is my x, unknown one. This is my x. Okay, and this will be 0 in the lower part. This is lower triangular matrix, and the upper triangular matrix, these both will be unknown. So y and z, this will be y, z, and something p, and this will be 0. And you can easily find, you will have equation, you will have 4 equation. You can easily find the values. Okay. So this is what the approach, you can find the value, and here the answer will be D. If you will multiply these both, you will easily get this. Okay, next one. So the next question is something related to algebraic equation, and in this case, the root of algebraic equation. What are the root in this case? So here, if I have minus 1 is one of the root. So if I will find anyhow one root of this equation, so x cube plus x square plus x plus 1 is equals to 0. All the things are plus, then we can easily put minus 1. We can check it as at minus 1. If it is true, then we can find another all roots. So it is minus 1 plus 1 minus 1 plus 1. If it is 0, it means minus 1 is one of the root. So minus 1 is one of the root. It means what? This is not correct. This is not correct. So from these both should be correct. Now, if minus 1 is one of the root, then now what I will do, I will just divide this polynomial x cube plus x square plus x plus 1, and I will get another one. Otherwise, you can just put it in this equation. It should satisfy. So this one will satisfy. This is what iota here. Okay, it like this will satisfy, and this will give the answer. Okay, so the next question will be like this. So basically, solution of variable x1 and x2, this is same as simple. See, in this case, what is the Jacobian matrix? They are asking about the Jacobian matrix. So what is Jacobian matrix? So if you have some function, like let's say my equation number 1 is something f of x is nothing but tan of x2 sine of x1, or it is x2 x1, or I say, let's say it is my f of x only, x1 and x2 minus 0.8, and second one is x1, g of x1 and x2 is tan of x square tan of x2 cos of x1 minus 0.6. Okay, here what is the Jacobian matrix if I have x1 is equals to 0 and x2 is equals to 1? Jacobian matrix is something like that: f of x1, the partial derivative of f, the partial derivative of f with respect to x1, and the partial derivative of f with respect to x2. And the partial derivative of g with respect to x1, partial derivative of g with respect to x2. What is the partial derivative? In this case, if you are differentiating with respect to x1, then x2 will be constant. In this case, my x, this is x1. So if I am going to differentiate with respect to x1, then tan of x2 will be as it is. This will be tan of x2 into cos of x1. And if I'm going to differentiate with respect to x2, then it will be tan of sine x1 will be as it is. Now in this case, this is what x1 here. So if I'm going to differentiate with respect to x1, so it will be what? It will be tan of x2 sine of x1. Okay, and because it will be 0 while differentiating with respect to x1. Okay, and next one will be if I will differentiate with respect to x2, then it will be 20 of x2 square 20 of x2 minus 10 cos of x1. Now on putting all these value x1 and x2, if x1 is equals to 0 and x2 is equals to 1, I will get 10 0 0 10. So this will be the correct answer. Next question is again related to Newton-Raphson method. You can easily do it. Next question is related to Newton-Raphson method, or basically the error observed in the second. So how can you find the error in this case? So first of all, simple, if you will put the value at second iteration, okay, as taken x1, so f of x1, what will be the e to the power 1 minus 1, 0 minus 1, and another one while you are calculating through numerical method, you can easily find error. This is something like that in a continuous function, f of x does not have any root in the interval a to b. So it means this is my a and this is b. So this is my function. Okay, f of x. It has no root in this interval a to b. So what condition will be true? So obviously in this case, the condition will be true is like that. F of a into f of b will be greater than 0. Because of that, if there is any interval for the z of x, so in this case z of a into z of b will be 0. Because of that, at where one case, see how like, what is the function's behavior here? This is a and this is b. Now a is like this, and or let's say b is like this. This is here, this is here, this is positive, this is also positive. The function at the both point, the function value is positive. It is positive and positive, it is positive. So it will be C. Okay, now if there is a one root in this interval like this, it means that now the function value is here positive and here negative. So negative negative into positive less than 0. So otherwise, if there is any real root, so this may hold this condition. Okay, now the correct answer is here only. Okay, next question is related to again Newton. It is related to bisection method. Bisection method is something like this. This is saying that what is the number of minimum number of iteration required in this case. So in the bisection method, it is b minus a upon 2 power n divided by less than epsilon. Epsilon is that for what accuracy you are searching for the minimum number of iteration. So in this case, basically, they are achieving the accuracy of 0.001. Okay, this is 0.01. So this is what the epsilon value. Now you can put epsilon here. Okay, you can put epsilon as 10 to the power minus 3 here. So what is b? B is my 2. So 2 minus 1 upon 2 power n less than 10 to the power minus 3. And after solving this transcendental equation, you will get n is equals to 10. So the 10 number of minimum iteration will be required for the bisection method to solve this solution. Okay, this is what one of the question. Now in this case, here we have a piecewise linear function is plotted using thick solid line in figure. So in the below, the plot is drawn to scale. Okay. If we use the numerical, if we use Newton-Raphson method, okay, here, if we use Newton-Raphson method uh, to find the root f of x is equals to 0 at x0, x1, x2. So these are the root basically. Okay, would be. So what are the root basically in this case? So while finding the root and while calculating it through Newton-Raphson method, we don't have any equation here. So just use the basic concept of Newton-Raphson method is just intersection. So first you will have to find the intersection. So starting with the slope intersection. So the starting from x0, this is my x0. So at x0, the slope is what? What is the slope? Y2 minus y1 upon x2 minus x1. So this is what the simple case. It is 1 minus 0.5. 1 minus, this is another point, 0.5 divided by 0 minus 0.5 because this is at 0. We are considering it as at a 0.5. Okay. Now the y-interception is 1. Here the y-interception is 1. Now the simple equation, what is y mx plus c? We are making the equation because we don't have any polynomial to find Newton-Raphson method, to apply Newton-Raphson method. Otherwise we can directly put it. Now here the line of equation, the equation of line is minus 1x plus 1. This is my function. This line cuts at x-axis. It means y is equals to 0. So at x is equals to 1, since x is equals to 1 is greater than, so x is equals to 0.8 here, sorry. So x is equals to 0.8 here. So after that, cut the line C and not line B. So basically this is line B, line C. So this is line C, cut at line C. Now the perpendicular at x1 is cutting line B and basically root will be 0.6 here. It is 0.6 is the root. Okay, if we will put the perpendicular from here, then we'll get root is 0.6 and root is 1.55. Oh, sorry, 1.3. 0.6 and 1.3 are the root. So slope of again we can find slope of the line like 1 minus 0.5 divided by 2.5. This is what? This one minus this one. Now we can find the slope of this line. Then this will be minus 1.55. It will be 1. Again y is equals to x minus 1.05. We have two equations. And again we will have one more equation. Using these all equation, apply Newton-Raphson method and you will get easily the solution. Next one will be the Newton-Raphson scheme. Now here, see, in this case, the Newton-Raphson method can be used to compute the square of r. What is the formula? That's previously we have derived this. What is this? This is nothing but root of. This is the just formula of the root. Or either you can solve it using this. If it is my xn plus 1 is equals to 1 by 2 xn plus r upon xn. Now if it is my alpha, okay, if it is alpha is equals to 1 by 2 and if it is also alpha r by r, because of that the root of function is same. Now we can solve this equation. We will get alpha is equals to root of r. So this is basically the square root of r. Again, this is what the solution using Newton-Raphson method. It is more frequently asked question in this case. Again, it is something related to applied bisection method. And what is the number of iteration? You can easily find b minus a upon 2 power n less than epsilon. So what is your desired accuracy? You can find it as like this. But in this case, you have interval. Okay, we have asked about the interval. So basically, how well you find? You can't apply this one. So what is the basically given? What is the formula given here? Wait, just a minute. Wait. This one, yes. Now you have interval. So this is what a, b. Just applying this formula, what is the after iteration? Okay, this is the, okay, these are, okay, this is solution. Sorry for that. Converging to a solution. So what is the solution? Xn is equals to a plus b by 2. This is the simple formula using this. Okay, bisection method formula. and the numerical integration of this, following this numerical integration, then what is the question? Question is that with respect to the numerical evaluation of defined integral k is equals to a to b of x square dx, where a and b are given, which of the following statement is or are true? Okay, the value of k obtained using trapezoidal rule is always greater than or equal to the exact value of the defined integral. Yes, in the basically in trapezoidal rule that we have earlier seen in that case of parabolic equation, if we take 2 point, this will be like this. Okay, this will be like this. This is the area, or it will be like this. This is the area. So it is more. No? It means the trapezoidal so will give more answer through always it will be more from the exact solution. So first will be the correct. And the value of k obtained using Simpson's rule will be the exact to the defined. Yes, because of that it is a second order polynomial. If it is a second order polynomial, then Simpson rule will give the exact solution of this problem. Yes, of course. So these both are true. So this is the simple concept. Here it is again numerical method, Newton-Raphson method. You can easily solve this kind of problem. We have solved several types of problem. Here in this case, they have asked about the what is the value of L22. It means if you are doing LU decomposition of this, so what is the matrix 2, 2, 4, and 9? If the diagonal element of U are both 1, okay, so it is L11, 0, L2, L12, sorry, L21. This is L21 and this is L22. And U11, it is 1. Okay, the diagonal element of upper triangular matrix is 1, 1. So now what is the case? Okay, so this is the format of code. This is nothing but the code approach of the basically LU decomposition. Now in this case, basically L11, what will be L11 here? So if I will compare using this, so my L11 will be, okay, if I will multiply these both, I will get the solution. Yes, if I will compare it as like this, wait. Okay, just let me multiply this. So this will be L11, 0. Okay, it will be L11. This will be L11 into U12. And this will be this, 0. This will be L21 and 0. Okay, this will be U12. Just multiplying these like this equation. 1, 2. Okay, this and this plus L22. Okay, now on comparing L11 is equals to 2. Okay, 2, 2, 4, 9. Okay, and L21 is equals to 4. Okay, then L11 U12 is equals to 2 and L11 is 2. So U12 is 1. If U12 is 1, then 1 plus L22 is equals to 9. So L22 is equals to, wait. This one will multiplied by, okay, L21 is also here. So yes, into L21. L21 is 4. So it will be 9 minus 1 or wait. This is L21, U12 plus L22 is equals to 9. So this is 1 and this is 4 plus L22 is equals to 9. Yes, L22 is equals to 5. So you can easily multiply. This is the court approach of the LU decomposition. Okay. Next question is, okay, this is in the computer science engineering. The secant method is used to find the root of an equation. Is started with two distinct estimate x1, x of a, x of b for a root. It is an iterative procedure involving linear interpolation to a root. The iteration slope is like this: f of xb is very small, and the f of xb is the solution. The procedure is given below. Okay, this is the procedure. basically in the form of code or something like this. So basically, what is the formula of secant method? They are asking about the formula, simple formula. So the formula is nothing but f of b minus x of b, f of x of a, and f of a minus f of b divided by f of b minus f of a. Why this? Because they are saying that f of xb is the very small, then it is a slope, minus f of x, and xb is the solution. That's why this is the formula of secant, or otherwise you can easily get from this code or this algorithm, you can easily get this. Next one, it is a simple approximation, and the velocity approximation using this, what, the integration. This is simple 0 to 20 v dt, and you can fit the polynomial, or you can use the Simpson 1 by 3, that is h by 3. What is this? F of 0 plus y of 0 plus yn twice of all even number and 4 of all odd number. You can find this is what your y0, y1, y2, y3, y4, y5, y6, y7, y8, y9. Put all these value and you will get the answer as 309.33. Okay, next will be the same Euler method. You can easily calculate using Euler method. Okay, yeah, this one is the Euler corrected method. So it is what the predictor corrector Euler. It means if you are getting like this, yn plus 1 is equals to yn plus 1 by 2 h, and this will be f of xi or xn yn. This is the formula. Okay. Now here xn plus 1 will be asked from, yn plus 1 will be asked from here, and this can be find, or basically star is the formula of Euler Euler modified method. Okay, then this will be yn plus 1 is equals to h f of xn comma yn. You will use this value here. Okay. Next, this is what the question, and here it is the following table list an nth order polynomial. Okay, this is the nth order polynomial. It is a finite difference table, and in this case, in the following table, del 4f, basically in the following table, by calculating del 4f. How will you calculate del 4f? You will just minus this, and this. We'll get del 4 and all the values in this case. So the order of polynomial. So what is the order of polynomial? The forward finite difference are evaluating from this to this. If you will find, then you will get del 4 of f. We get as 7.2 into 10 to the power 3. If it is okay, after that del 5f we are not able to find it. It means it is a fourth order polynomial. Because of that, we are able to solve only up to del 4f. Okay, so the next question. Okay, so this is all about the numerical analysis question in the engineering, or basically most of the all questions are related to the integration especially and Newton-Raphson method. So these two are the method, and some questions are related to Euler's method or Runge-Kutta method. Okay, thanks for watching my video. Keep watching MS Maths, and for more video you can subscribe the channel, share the video, and if you are watching till the end, please subscribe the channel, share with your friends, and like the video. Press the bell icon. So thanks for watching my video. Keep watching MS Maths. Thank you. Bye-bye.